After the tough fight with Harry Potter, the remaining Death Eaters have found their way to wake the Dark Lord up from death. Beware, people! Voldemort is now ready to take revenge and kill any muggles who are there to prevent his evil deeds. The Dark Age will come once again. But, of course, our hero, Harry Potter, will not allow the massacre of mankind to happen.
Where is this place? Oh my god, this place is full of muggles living here. No tomorrow from them from now on.
Don't be so arrogant, Voldemort.
Harry Potter, where you always appear when about to have fun. You stupid boy. Expelliarmus! Stupid boy!
Wait! Sorry to ask you this, but are your wands made of fluorescent sticks?
Of course!
Have you ever wondered why your wands have different colors?
Duh!
A fluorescent stick is a single-use translucent plastic tube containing isolated substances, which when combined make light through a chemical reaction-induced chemiluminescence, which does not require an electrical power source. Fluorescent sticks give off light when two solutions are allowed to mix. The sticks consist of a small fragile container within a flexible outer container. Each container holds one of the two solutions. When the outer container is bent, it breaks the inner container, releasing the first solution into the second solution. After breaking, the tube is shaken to mix the two components. The fluorescent stick contains two chemicals and a suitable fluorescent dye, which is sensitizer or fluorophore. The chemicals in the glass vial are a mixture of the dye and diphenyl oxalate. The chemical inside the plastic tube is hydrogen peroxide. The fluorophores in this reaction are the chemicals that provide the color of the light stick. By mixing the peroxide with the phenyl oxalate ester, a chemical reaction takes place. The ester is oxidized, yielding 2 molecules of phenol and 1 molecule of peroxy acid ester. The peroxy acid decomposes spontaneously to carbon dioxide, releasing energy that excites the dye, which then relaxes by releasing a photon. The wavelength of the photon depends on the structure of the dye. The essence of the various colors of fluorescent sticks is flame reaction. More fundamentally, electrons transition. Electrons transition refers to the valence electrons jump from orbital with lower energy level to higher energy level, or reverse. In each process, the transfer of electrons will result in absorption or release of one photon. Photons are the particles which light is made up of. Electrons transition includes self-transition as well as stimulated transition. Electrons are in equilibrium without external stimulation. In this case, electrons can either jump to higher energy level or transfer to lower energy level. Overall, the electrons are in transition equilibrium. The equilibrium will be broken when there is external stimulation. When electrons absorb photons, electrons will transfer to orbital that is further away from nucleus, which means the electrons transfer to higher energy level. However, these electrons are not stable, and they will easily return to their original energy level. In this process, the energy released is in the form of visible light, which wavelength between 400 nanometer to 760 nanometer. In the equation, h is the Planck constant, v is the frequency of wave. The higher the difference between the two energy levels, the higher is the frequency of wave released, which means the color tends to be more like blue or purple. Similarly, the color tends to be more towards red if the difference between the two energy levels is small.